Hello, so today we will be discussing about a fixed probability vector of a stochastic matrix. You must know that fixed points are very important uh, properties, okay, one of the important things that we study in mathematics. Whenever we are talking about fixed point, you will need functions. Okay, for example, okay, if I give you fx equal to 1, okay, so if you, okay, maybe from okay, let us make it simple from natural numbers to natural numbers. Okay, so we are having a function and it is a constant function fx equal to 1. So if you notice 1, it's going to 1. Even the number 2, it's going to the number 1 because f2 is equal to 1. Okay, 3, again it's going to 1. If I ask you the question which point over here it's fixed, you can immediately tell that the point 1 is fixed under the function f. That is 1, it remains as it is. 1 is going to 1, it doesn't change. That is why the point 1 is fixed. Okay, suppose if we are having fx equal to x. Okay, let us make it a bit harder, f from r to r, okay, from real numbers to real numbers. If I ask you which point is fixed, then you can immediately tell that 0 is fixed, because if you find f0, it will be equal to 2 times 0, which is 0. So the point 0 is fixed. 0 is fixed. Okay, so fixed points, they are very important, and we only study them if there are functions. Okay, so now, but over here what we will do, since we are dealing with matrices, okay, matrices, they act on vectors. Okay, matrices, they are linear transformations. Linear transformations are functions. Okay, so that's why we can talk about fixed point of matrices as well. Okay, but over here we will be calling them fixed vector. So vector v, okay, or vector u, okay, it is having n coordinates, is a fixed point, or is a fixed vector of a matrix A n by n. We are having n coordinates, so over here will be n by n if ua is equal to u. Okay, it's just like writing something like this, f u equal to u. Okay, the same thing. Okay, but over here you must remember that there are some authors, okay, there are some authors who use this one. Again, they're not wrong. Okay, it's just a different terminology. Okay, a different thing. Okay, but anyway, it's again fixed. But the important thing about using this kind of terminology versus this one, it's that if you are using this one, you must know that u, it will be a row. It will be a row matrix. A remains as it is. Okay, it will be matrix. U will be a row matrix. Whereas if you are using this terminology, you must know that U, it will be a column matrix. Un equal U1, U2, Un. Okay, so that is the difference between this one and this one. But throughout, I will be sticking with this notation, okay, where we are using U on the left side. Okay, so this one can be defined for any square matrix. Okay, so what happens if, okay, we can actually do more, okay, since we are dealing with Markov chain, and Markov chain is relating to stochastic matrix, which we had studied. Okay, so over here, instead of a regular square matrix, we can even define it for a stochastic matrix. Matrix P, let us call it P. Okay, and since we are dealing with stochastic matrix, okay, it will no longer be an ordinary vector. Okay, we are more interested in a fixed probability vector. A vector u is a fixed probability vector of a stochastic matrix P if the same definition, UP is equal to U. Okay, but also since it is a fixed probability vector, you must know that if you add all of them, it will be equal to 1. So the sum of the coordinates of this vector will be equal to 1, and they are all non-negative. So this is how we define the fixed probability vector of a stochastic matrix. One thing that you should note here is, okay, this fixed vector, it may not exist. Fixed probability vector of a stochastic matrix, it may not exist. But okay, but if the matrix is stochastic as well as regular, but if the stochastic matrix is regular, that is a regular stochastic matrix. So if the stochastic matrix is regular, then fixed probability vector always exists. It not only exists, but it is also unique. Okay, so there is only one fixed probability vector of a regular stochastic matrix. So that is what we can say. So with this being said, now let us just go ahead with an example. Okay, let us make it a 2 by 2 matrix first. Okay, show that BA is U equal BA is a fixed vector of the matrix A B1 minus B. Okay, so we are having a 2 by 2 matrix. That is why over here we are having 2 coordinates. Solution. Okay, let us just find U, since we are writing it from the left hand side, so it will be a row. So we will be having BA. You multiply it with 1 minus A. Let us find out how much are we getting. So multiply this matrix with this matrix, you will be getting B minus BA plus AB. And if you multiply this row with this column, you will be getting BA plus A minus AB. This you will be getting B, and over here again you will be getting A. Okay, so you can write it equal to U since U is BA. So that is why that is UA will be equal to U. So hence it is a fixed vector. Hence U is a fixed vector of A. Okay, so it's very simple if we have to show that it is a fixed vector. Okay, but it is slightly more difficult if we have to find the fixed vector. Okay, so we are not given in advance, but we need to find it now. Okay, so what we will do, let us make it slightly difficult. Let us make it a 3 by 3 matrix. So in this second example, what we will do is we will now try to find a fixed probability of vector of this regular stochastic matrix. This is slightly different from the first question, because in the first question we just need to prove that a given vector is a fixed vector. Okay, but actually over here we don't even have a vector, we need to find it. So this is slightly difficult. Okay, but you will see that the process is really smooth. Okay, I mean, like, it's not so difficult because we are having only 3 by 3 matrix. Maybe if the size of this matrix is bigger, then of course it will be complicated. Okay, but anyways, let us just see what the question is saying. We need to find a fixed probability vector, and over here I am using the word the, because you know that we had learned that for a regular stochastic matrix the fixed probability vector is unique, so that's why I am using the word the and I am not using the word so let's see. Okay, so let U, if it is a fixed probability vector, then the sum of the coordinates should be equal to 1, and since it is a 3 by 3 matrix, we will make it as a vector with 3 coordinates. Again, if you notice, we are having that the sum is equal to 1, and over here we also need the restrictions that xy should be greater or equal to 0. Okay, so let U be the fixed probability vector. So if you multiply U with P, so UP will be equal to U. So U, since you are writing it on the left hand side, it will be a row x, y, 1 minus x minus y times P, which is 0, 1, 0, 0, 0, 1, 1 by 2, 1 by 2, 0. It will be equal to x, y, 1 minus x minus y. UP is equal to U. So multiply this row with this column, you will be getting 1 minus x minus y by 2. Multiply this row with the second column, you will be getting x plus 1 minus x minus y upon 2. Again, multiply this one with this third column, you will be getting y. 3 coordinates here, 3 coordinates over here. All we have to do is compare them. So each coordinate, the first coordinate will be equal to the first coordinate multiplied by 2. So you will be getting 1 minus x minus y by 2 equal x. And over here, okay, we can simplify this one, 2x. So you will be getting 1 plus x minus y by 2, which is equal to y. And the third one, which is y, equal 1 minus x minus y. So over here you are having, okay, let us simplify, you will be having 3x plus y equal 1. Over here, if you simplify 2y, 3y, 3y minus x, 3y minus x, 3y minus x, it will be equal to 1. And over here we can have 2y plus x will be equal to 1. Okay, take this one to the left hand side. Okay, so you are not saying that we are having 2 variables but 3 equations, but nonetheless, okay, we can solve any 2 of them. Okay, you can take any 2 that you like. Okay, so let us just name this one as equation 1, this one as equation 2, this one as equation 3. Let us solve equation 1 and equation 2. Okay, so let's say 3x plus y equal 1, which is the first equation, and 3y minus x, so minus x plus 3y equal 1. What we can do over here is we can multiply this one with 1 and multiply this one with 3. Okay, so you will be having multiply this one with 1. You will be having 3x plus y equal 1, and over here you will be getting minus 3x plus 9y equal 3. We can add them. If you add, you will be getting 10y equal 4. So you will be getting y equal 2 by 5. Okay, now what we will do is substitute in 1. Okay, we actually did one by solving 1 and 2, the equation 1 and equation 2. So substituting in 1, in equation 1, you will be having 3x plus 2 by 5 equal 1. So you will be having 3x equal 1 minus 2 by 5. So you will be having 3x equal 3 by 5, which gives you x equal 1 by 5. Okay, you can actually verify. Okay, we did not even need this third equation, again because we are having 2 variables, 3 equations. Okay, we just need 2 equations, 2 variables, 2 equations to solve them. But anyways, you can easily substitute the value of x and y that you obtain from over here. You will see that it will satisfy this third equation as well. So putting x equal 1 by 5 here, putting y equal 2 by 5 here, this third equation is satisfied. Okay, so just to not leave out this equation 3, otherwise it will be too lonely. Okay, so we are getting x equal 1 by 5, y equal 2 by 5, hence the probability vector is q equal x, y, 1 minus x minus y. So x is 1 by 5, y is 2 by 5. Substitute x and y over here, you will be getting 2 by 5. Okay, which is the required answer. Until next time.